Hi everyone, excited to be here. My name is Carmi and I am the co-founder and VP R&D of Applitools. We're a company that provides a cloud service for automated visual testing. And as part of my job, I get to meet a lot of developers and testers, and I'm always curious to learn how they do visual testing. Surprisingly, many of them don't know what visual testing is, and many others think that I'm asking them whether or not they're using Sikuli. So the main thing that I hope you'll take away from today's talk is that you understand what visual testing is and that you can and should automate your visual tests. But if in addition you also remember that visual testing does not equal Sikuli and tell that to everyone you know, that would be a huge bonus for me. Okay, so we have quite a lot to cover today. We'll start by explaining what visual testing is and why it should be automated. Then we'll review some of the tools that are available out there and the technology that's behind them. And next we'll discuss how automated visual testing fits in your development lifecycle, and there will be time at the end to answer any questions that you may have. If you have an urgent question, so feel free to ask. If it would be a long answer, I'll ask to defer it to the end. And I can't really see the audience very well, so try hard to show that you have questions. Okay, so what's visual testing? It's a quality assurance activity aimed to verify that the graphical user interface appears correctly to users. Now, this goes beyond the traditional functional testing that you used to do with tools like Selenium, where you actually test the functionality of the application through the UI. What we're focusing about here is making sure that the UI itself appears correctly to the end user. We want to make sure that each UI element appears in the right color, shape, position, and size, that it doesn't overlap or hide any other UI element. And this type of testing has become increasingly difficult to perform in recent years, mainly because of the explosions of browsers, devices, operating systems, and screen resolutions that our applications are expected to run on. So here you can see an example of a visual bug. This one is from the Microsoft Azure Management Portal. You can see here that the graph exceeded the expected bounds of the page. This one is from the Financial Times. You can see here the article title that overflowed and hid some of the article body at the bottom. And this one is from the Amazon Prime Day on July 15th this year, and this is how the website looked like for several hours for certain users. Now, I'm sure that you've all seen these type of bugs, and you understand their severity. They are very embarrassing, and they can hurt the company brand, but in many cases, they can also completely cripple the functionality of a website or an application and end up costing a lot of money, as probably happened in this case. Okay, so we do understand that we need to do these visual tests, but why should we care about automating them? So there are many reasons for that, but the most important one is that the test metrics is just too big to cover manually. We all know that if a site looks good on Chrome, doesn't mean that it will look good on IE, and if an application looks good on a widescreen, it doesn't mean that it will look good on a smartphone. So we have to test on all these different environments to make sure that the application does look good. And of course, if the application is responsive, and most modern applications are, then we also need to take into account all these different layout modes that the application supports and make sure they do what they're supposed to do on all these different environments. If the website or application is also localized, we need to take into account the different fonts, images, resources, and content. And of course, if we don't even change one line of code, we still have third-party upgrades that we need to factor in. So it could be that the browser upgraded and introduced some incompatibility or bug into our site or application. So we constantly have to test on all these environments and do all this work, and it's quite impossible to do manually. What makes things even more difficult is the trend in the recent years to keep shortening the release cycles. So if we consider continuous deployment, which is the recent hype, companies doing continuous deployment release to production several times a day. And with such short release cycles, there is hardly any time to do any type of manual testing, let alone making sure that the application looks good on so many execution environments. And with mobile apps, it gets even more difficult because it's much harder to roll back changes. If you have a bug, you're stuck with it for some time in production. You can push daily to the App Store, and even if you manage a way to work around that, and frequent updates will just upset your customers because they take up battery and data. And in general, there's a much higher quality bar for mobile applications simply because mobile users are much less tolerant for UI and UX bugs. So because of all these reasons, many respectable and known companies have incorporated automated visual testing into their development processes for years now. They've built excellent tools and they share them with the community. And there are thousands of other companies that are actually using these tools on a daily basis, and so should you. Okay, so let's move on and take a look at some of those tools. But before we do that, let's go over the basic workflow that all the tools share. So there are 4 steps to this workflow. In the first step, you basically drive the application under test and take screenshots. In the second step, the tool takes those screenshots and compares them with baseline images. These baseline images define the expected appearance of the application, and in most cases, these are screenshots that were taken in the past and were approved by a tester. In the third step, the tool generates a report that includes all the baseline images, the new screenshots that were taken, and any differences that were found during the test, and produces a report for us. In the first step, a tester looks at that report if there were any changes and has to decide for each change if it's a bug or if it's a valid change to the application, in which case he needs to approve the new screenshots so they will be used as baseline images for subsequent runs. So of course, there's the first time you run a test, you still don't have a baseline images, so the first run will usually create those baseline images, and starting from the second run, you always have something to compare against. So now that we know how these tools work in general, let's see the first demo, and that would be one of my favorite open source visual test automation tools that's called WebDriver CSS that adds visual testing capabilities to the WebDriver I/O. So for those of you who are not familiar with WebDriver I/O, it is a Selenium-based client that is written in JavaScript. And basically, this is a simple test that we'll use to add visual testing to. It should be quite familiar to you. You create an instance of the driver, and then you specify that you're interested in running a local Chrome browser. And the test is quite simple and trivial. It opens up the browser, navigates to WordPress.com, and waits for 10 seconds. Very simple. So what we're doing now is that we're adding the WebDriver CSS stuff and actually augmenting WebDriver I/O with visual coverage abilities. So we create an instance of WebDriver CSS, and we use it to initialize the driver. And when we do that, WebDriver CSS simply injects that functionality into the driver object. And inside the initialization, we can also specify the screen width that we are interested to test the application under. This is very useful if you have a responsive website or application that you want to test, because what it will do is before the screenshots are obtained to be validated, the browser will be resized to those widths, and it will force the site to assume the required layout, as we will see with WordPress. And if we look at our simple test, then right after we will navigate to WordPress.com, we actually take a visual checkpoint. This is done with the command WebDriver CSS. And we provide here a name for the checkpoint. In this case, it's WordPress. And then a list of elements that we want to validate. So we just have one element here. We identify it using any element selector that you used to use with Selenium. In this case, we specify the body element. And we name that specific element. In this case, I call it homepage. So let's run it and see what happens. OK, so you can see the browser opening. Being resized. Great. So because this is the first time you ran the test, if I look at the folder where I ran WebDriver CSS, then basically you can see that two images were created, two baseline images. For the first one is for the WordPress checkpoint, for the homepage element, and for the 360 pixel width that we saw. If we look at this image, you can see that actually it consists of a full page screenshot of that page. And as you probably know, Chrome does not support full page screenshots. It will just give you whatever is visible through the viewport. So WebDriver CSS actually takes care of that for you, and it automatically scrolls the page and takes multiple screenshots and actually simulates a full page screenshot for you, which is great because you get more coverage. And of course, we have the 700 pixel wide version, which is different because WordPress is a responsive website. What we're going to do next is we are going to run the same test exactly, only we are going to inject some JavaScript into it just before we take the screenshot, and we'll simulate a difference. This could be either a bug or maybe a change to the application. So the way we'll do it, we'll just find the create website button element by ID, and we'll just hide it. Okay, so let's run this test again and see what happens. Okay, so you can see that the button is gone. Great. So if we take a look now at our folder, you'll see that we have two new images that have a regression suffix. And this is WebDriver CSS way of telling us that actually it took screenshots that did not match the baseline images. If we look at those screenshots, you can see that they show you the resulting screenshots that we're taking where the button is missing. In addition to that, there's a diff folder that shows you diff images that indicate the differences that were found. So in this case, you can see the differences highlighted in pink. So you can see how easy it is to just take a regular WebDriver test and just with a few lines of code, turn it into an automated visual test that can also capture visual differences on the screen. Of course, it is also possible to wire in some assertions so that if differences are found or if they exceed a certain threshold, then the WebDriver URL test will fail as well. So you don't really have to go and search in the folder for diff images. It will just fail. Okay, so let's drill down into the workflow and see, learn a bit more about each of the steps and how different tools implement them. And we'll start with driving the application under test and taking screenshots. So when we're considering taking a screenshot, it sounds a trivial thing. We all know that a WebDriver has a get screenshot method. So what's the big deal? So of course, there are certain nuances that can complicate matters, and different tools provide you with different ways to cope with them. So first, we already saw with WebDriver CSS the ability to simulate a full page screenshots. Not all the tools provide that. Many of the tools just let you handle whatever the browser returns. Some of the tools will allow you to take screenshots of specific regions or elements within your page. The others just let you deal with the whole thing. If you have iframes or divs with scrolls inside your application, then some of the SDKs will allow you to very seamlessly capture the content of those iframes. It will automatically change the context of the WebDriver, scroll and stitch and provide you with the full content of the frame, and then return the context back to the original one, which saves you work and time and development. There are issues with device pixel ratio. So for instance, if you're running your test on a Mac with a Retina screen, you'll get screenshots that are twice as big as you would expect them to be. Some SDKs will normalize those screenshots to the expected size, so you can still compare them with images from computers without a Retina screen. Especially with Appium, sometimes there are problems with rotation. You get an image that is rotated while it shouldn't be, so some of the SDKs can identify it and correct it. As we've seen with WebDriver CSS, some of the tools allow you to specify various viewport size to take for each validation point. This is important for testing a responsive website. Page preparation is also something that some of the tools provide. For instance, it can be used so that before each checkpoint, you can hide some dynamic elements or maybe mask away certain regions of the page so that you don't end up with sensitive customer information in your test reports. And some of the tools also help with the page stabilization simply because of the fact that they already have the baseline image, so they know how the page is expected to look like. So instead of just taking a screenshot and moving on, they can continuously poll and try again and again until a match is found, meaning that the page is stabilized, until a certain timeout is reached, in which case they just consider it as a mismatch and move on. Now, there are more than 30 open source and commercial visual test automation tools that are out there today, and you can roughly group them into two groups. The first group is the quick feedback tools, as we call them, and they shared a similar setup where the tool actually renders the screenshot with a headless browser. Commonly, that would be Phantom.js and Slimer.js. And the test itself will normally be based on a configuration file that specify URLs to check. Okay? The motivation to use tools like that is basically if you want to get fast feedback on code changes. So the classical use case here is to have is where a front-end developer is now developing a new component or implementing a page, and you just want to make sure that the changes that you just did not affect any other pages or components that he didn't mean to affect. And so he wants to run something locally that will be very fast. It should run in the background so he can continue to develop or do stuff while the tests are running. And he doesn't want to really work hard about writing tests and maintaining them, so he just uses a configuration file, which is good enough. The disadvantages of this approach are quite obvious, and you get partial coverage. So if you rely on Phantom.js and Slimer.js, basically you're limited to Safari and Firefox, and you completely ignore Chrome and IE, which are rather important browsers. In addition, because you rely on a configuration file to drive through the application, you have quite limited abilities to navigate the application and reach certain UI states. And another risk is that you are risking with testing stale browser versions, because these headless browsers are not always up to date with the latest releases of the browsers. So you might have a bug in Firefox in the recent version, but still you won't find it because you're using a Slimer.js, which uses an older version of the layout engine. The other category of tools are the tools that we call visual coverage tools. And the setup there usually is that these tools render the screenshots using real browsers on a variety of operating systems, and they run the test in parallel, usually with WebDriver and using a Selenium grid to handle all these different environments. And the tests themselves will usually be code-based. This could be like a straightforward WebDriver test-based test or with some DSL built on top of that. And the motivation here is quite different from the first category. These tools are good if you want to verify that your application does look good on real browsers in real execution environments, and you really want to test as many UI states as possible and execute those tests in parallel. Okay, so the downsides of this approach is that basically you have to invest time in building a test infrastructure, so you need to set up a Selenium grid and all these environments, or use an external service to get that. And you also need to know how to work with Selenium, and you need to write tests and maintain them. But in general, if you're a test professional, you probably already have all that in place and you have the knowledge, so this is not really a disadvantage. On this slide, you can see the full list of all the visual test automation tools that are based on Selenium. We won't read them out one by one, but a few important things to mention is that, first of all, for every language binding that Selenium has, you have a corresponding tool that will allow you to easily add visual validation coverage to. Okay. The other thing is that with Applitools Eyes, you're not limited to WebDriver alone. You can also test any mobile application using Appium. You can also see that the majority of tests are code-based, and a few of them are configuration tests because Most of these tests fit into the second category that we've discussed. This slide shows some of the non-Selenium-based tools, and as expected, the majority are based on configuration files, and even those that are based on code usually rely on JavaScript, and that fits with the front-end developer theory. Okay, let's move now to the second step of comparing screenshot with baseline images. This is basically the most challenging and complicated step to get right as far as the tools are concerned. And as Boromir said in Lord of the Rings, one does not simply do bitmap comparison. And the reason is that if you do that, you get a lot of false positives. Eventually, you hate the tool and throw it away, and we don't want that to happen. And when we're talking about false positives in the context of visual testing, these are the cases where the tool tells you there's a difference, but you cannot see it, okay? Or you don't care about this difference. So there are many reasons for these false positives, and I will show you some of them so you can understand that these are all specific problems that can be solved and not just something that can't be dealt with. And the first one has to do with something that is called anti-aliasing, and I'll explain what that is. So basically, every time you draw a diagonal line on the screen, or if it's curved, then you get this staircase effect, these jagged edges. And this phenomena is called aliasing. And there are two problems with aliasing. First of all, it is extremely visible to human beings. And second, we all think that it's really ugly. Okay, so as you can see at the top left corner, the alias text, we see these jagged edges and it doesn't look good. Luckily, smart people thought about a way to overcome this. And what they built is an algorithm called anti-aliasing, which basically draws those edge pixels in different colors and intensities that kind of blur those jagged edges. And so it creates an illusion that the line is smoother. And as you can see, the anti-alias text at the bottom looks much, much better. So what's the problem with anti-aliasing? The problem is that if you're running your test on more than one machine, which makes sense if you're running your test in a lab or you have more than one guy in your team working with the tool, then you actually have two computers doing the anti-aliasing. And these computers can have different graphics cards, or different versions of the driver of the graphics card, or some different setting, or perhaps they're connected to screens with different capabilities which affect the way that the graphics card is working. And when that happens, those anti-aliasing pixels are different. Okay, so what happens is that the tool will pick it up, and unless the image matching engine is smart enough to detect the fact that these are anti-aliasing pixels that are invisible to a human, you will get false positives. So let's look how this looks in reality. So what we have here is an image with a white border, and this pink rectangle is magnified in the center. And I'll toggle between two rendering of the same image between two machines. Okay, you can see the pixels here below the white border, and you can see that they are slightly different. Okay, so it's hard to see them when it's magnified, and it's completely impossible to see them in the original image, but still, if you do pixel by pixel comparison, these are different pixels, and you'll get a false positive. Another common example has to do with brightness. So you can see at the bottom we have some text, and the word "day" is magnified. Okay. If we toggle between the way it's rendered on two different machines, you can see that the intensity of the pixels is quite different. In this case, it's so different that even on the original text you can see the difference. But then again, you'd never want your test to fail because of this reason. Despite the fact that you can see it with your own eyes, the reason you don't want it to fail is because I cannot imagine a situation where a customer will say, I don't want to buy a product because I have two machines and on one of them it looks brighter. So it's not really a bug that anyone cares about, and so you don't want your test to fail in such cases. And then again, you need to have a clever image matching engine to be able to detect that and ignore that. One of my favorite examples is the text positioning problem, where here you can see the upgrade account element that is moving. Now, anyone recognizes the site that this fragment comes from? Right, Roblox, everyone knows that. And the reason that upgrade account is moving is because to the right of it, there's a username. And every time you run a test, the username is different. So everything is aligned to the username and it's moving. So if you would like to still visually test and make sure that upgrade account looks good along with the icons that next to it, then you could say, sure, no problem. I'll just take the element that contains the upgrade account and I only verify its screenshot. So regardless of where it is on the screen, I can still make sure that it looks right. Well, the problem is that it doesn't really work. And as you can see here at the top, although upgrade account moves as a whole, you can see that each individual letter moves on is positioned on its own. So as you can see, the first letters A and C and the fourth letter, the O, are actually moving by pixel. So you need to have a very clever algorithm to detect that and be able to ignore that. The last example I'll show you has to do with image scaling. And what happens here is that whenever you have an image element in your application, and the bytes that are the source for this image come from an image that has a different size than the one that the target size that you want to have in your application, then basically you need a rendering engine to scale that image so it would fit to the target size. And what happens is, again, if you have two different graphics cards, for instance, then you'll get different pixels because the algorithm is different, okay? And if we look at that and at this magnified rectangle here and look at the pixel, you can see how different the pixels really are, although this is completely invisible to us in the original image. And if that's not all, then we need to take care of arbitrary 1 pixel offsets in element positioning, even on the same computer using the same web browser. There could be dynamic content like ads and dates and stuff that you want to ignore. There could be moving elements, just like that upgrade account example that we saw before. Sometimes you need to compare images of different size. And of course, the algorithms have to be really fast, otherwise our test will take forever to run. And there's bad luck Brian that even when he compares identical images, he gets a mismatch, but he's not here, so we're good. Okay, so luckily, we have those image comparison APIs to our help, and let's review some of them, the most popular ones that most of the tools rely on. So the first one and the oldest one is ImageMagick, which is a very powerful command line tool for doing image processing. It has all kind of neat functionality that you can do with images, like enlarge and scale them and change their format. And also, it allows you to compare two images. Now, basically, it does pixel by pixel comparison, but it also has a nice fuzzing feature where it actually averages the different pixels that surround each pixel when doing the comparison, and so it's able to overcome some of the rendering differences that we've described before. And the tools that rely on ImageMagick rely on an error ratio to decide if images match or not. So the way it works is that you would call a compare with ImageMagick. You provide the two images, image 1 and image 2, and ImageMagick will output the number of pixels that are different. Now, the tool will take this number, divide it in the area of the image that is being compared, and then you get an error ratio. And the tool will allow you to specify, for instance, a percentage. Let's say that if there is less than 0.5% of a change between the images, then I'll consider it as a match. If it's above that, it would be a mismatch. Another very nice thing that ImageMagick does for us is if we provide a third diff image, the name of just a file name, it will produce there an image which is image 2, on top of which all the different pixels are painted in pink, just like we saw in the WebDriver CSS example. The JavaScript engines are all, of course, written in JavaScript. They work very similarly to ImageMagick in the sense that they do pixel by pixel comparison and they rely on an error ratio to work, but they also add more functionality on top of that, which is very important. So Resemble.js, which is one of the more mature and older and popular matching engines, Phantom CSS is a very popular visual test automation tool that relies on it. Also does quite good handling of anti-aliasing pixels. Blink diff does also anti-aliasing and also takes into account the fact that humans are more or less sensitive to changes in certain color ranges, which helps also with some kinds of false positives. And there is a recent addition, Look Same, that also deals nicely with colors, but also can ignore the caret or the blinking cursor that we always have in forms. So it just looks for the pattern of the blinking cursor, and if the diff is just for that cursor, it will ignore it as well. And that brings us to our own Applitools Eyes engine, which was designed from scratch to compare computer-generated UI images. And as such, it handles all the issues that I showed you before and many others. It can handle also dynamic and moving content, compare images of different sizes. And another thing that's unique about it that it doesn't rely on any error ratio. So as long as a human can see the difference, it is highlighted, and if he cannot see it, it's not highlighted. And it has nothing to do with the size of the difference or the size of the image. And so on one hand, it can detect a minor change in a huge web page, like a comma changing to a period, which could be just 2 pixels different. But if, for instance, you have a web page with a table and one of the columns becomes 1 pixel wider, and that moves the rest of the page 1 pixel to the side and creates an 80% difference, it would still be able to identify that a human cannot see something that moved by 1 pixel, so it would just ignore that and not report it. Another thing that's special about this comparison engine is that it also supports layout matching, which basically means that it deconstructs the image into its components, paragraph, text, columns, and images, and compares the structures between the images. And this is very useful for actually validating extremely dynamic applications and also to do cross-browser and cross-device visual testing. And I'll show you how it looks like. Okay, so right now you can see the result of running a visual test on my Gmail account. Basically, right now you can see on the left-hand side a baseline image, on the right-hand side a screenshot that is being validated, and the differences are highlighted in pink. Right now we're doing a strict analysis, and we have this radar button that when we click it, it highlights all the differences so we don't miss out the small ones. You can easily zoom in and look at the differences that are found. So, for instance, we have a typo here on the More button. We have here a Google logo that moved. And we also have a change of color from blue to green in this search button. When we are doing strict analysis, as we mentioned before, there are cases where we have dynamic data that we want to ignore. So for instance, when I run my test on Gmail, every time I run the test, I have a different ad. And I don't want that to fail my test, so it's very easy for whoever is maintaining that baseline to just highlight that region so it would be ignored. Similarly, if we have a moving element like this Google logo, and that could be also the example of the upgrade account that we saw with Dropbox, then it's very easy to mark this area as a floating region. And when we do that, the tool automatically detects the area in which the element is moving, and you can further adjust it. And the result is that, in this case, as long as the Google logo appears the way it should be inside that blue rectangle, then the change will be ignored. However, if the Google logo would change or appear elsewhere on the page, this will be flagged as a difference and will fail the test. The other match level that we support is layout. And with layout matching, again, all we care about are structural differences. So in our case, the only structural differences between the tests now is just the Google logo moving. The fact that we have a typo and a change of color here no longer matters. And in fact, even if I remove this ignore region and the place where we have the changing ad, then again, this doesn't cause any mismatches because the structure is still consistent. So let's look at a more challenging example. So in this case, we have the Yahoo homepage, and the baseline and the screenshot to be validated were taken in a 24 hours difference. So you can see that the images are quite different, and the articles here at the bottom are different, but still, as far as layout is concerned, the pages are consistent. If I would change this to strict matching, then as you would expect, all the parts that are different, that are dynamic, are properly highlighted. But just to show you the strength of strict comparison, if I would do pixel by pixel exact matching, you can see that everything here is highlighted, just that differences are not visible to us, but the pixels are still different. The next example shows you a cross-browser visual test. So in this case, the baseline image was taken in Chrome, and the screenshot that we validate was taken on IE. Okay, and you can see here, if I toggle between the two, that the browser rendered differently, and that's okay. There's nothing wrong with that. You can see that the text here wraps differently, the fonts are a bit different, the positions are a bit different. All this is okay as far as layout is concerned, except for the fact that we have a missing element in IE, which is properly captured. The last example is for a cross-device test. So in this case, we have Twitter, once on a Samsung S4 and once on a Samsung S5. And you can, of course, Twitter is a very dynamic application, but here we have several violations. So first of all, the baseline image dictates that a paragraph should be aligned to the right of the image, and this is being violated here. That's why it's highlighted. And similarly, we have an image that we expect here that we cannot find here. So basically, these two issues are reported correctly, while the parts, the tweets in the middle that are okay as far as the layout is concerned are not highlighted. Okay. Next, we move to the third step, where we actually want to report the differences. So the majority of tools will report the differences by means of image files on the file system, just like we saw with WebDriver CSS. So you'll have the baseline image, the regression image, and the diff image there. Other tools like Selenium Visual Diff will go one step further and provide you with some kind of nicer report. It shows you all the tests that ran, number of failed validation points, etc. And we'll also show you a gallery with thumbprints of the screenshots, and that indicates the failures. And the last step, when we come to updating the baseline, then for all those tools that are based on file system, this basically means that updating the baseline means deleting the old baseline file, renaming the regression file to be named like the baseline file is expected to be, and that's it, you're done. You've updated the baseline. Although this looks a bit naive, it actually works pretty well if you actually keep those baseline images together with your code inside your source control. So whenever you change something, you get a diff image, you can send it to a designer to validate, and then you commit, if it's okay, you commit a new baseline together with the code changes, and it's documented well that way. Some other tools like Gemini provide you with a nicer UI, where you can actually see those files and see thumbnails of the new image and click a button that would actually cause it to copy and replace the baseline image. All the tools have an overwrite mode where you actually run a test with the purpose of just completely overriding the baseline. This is needed in cases where you have like a very big change that is going to affect the majority of the baseline, and you just don't feel like looking at each image and deciding individually if you want to change it. And of course, there's a lot of risk with doing this action, because you can accidentally place a bug into your baseline, and then the tool will not be able to detect it anymore, because it will be part of the expected appearance. So for that reason, one feature that is very important and unique to Applitools Eyes is what we call automated maintenance. And basically what happens there is that when you have a change, whenever you accept it, then the tool automatically looks at all the other changes that are out there. And if they are the same change, it could be in different pages and windows of the application, but if it is the same change, it is automatically accepted as well. So just to give an example, if you have a website and you just change the header of the website and it affected 200 images, then it's enough to approve that change just once and you're done with the maintenance. And it's completely safe in the sense that if there are other changes, they won't be accepted automatically. Okay, so we got to the last part, and we'll explain how all this fits in your development lifecycle. So the short answer is that it fits in all stages. If we look at the unit test stage, then it's very common for front-end developers to do visual testing for their components as part of the unit test. We've already described how the diff images can be used for reviews and how the baseline can be committed together with the code. For integration test, then basically we saw how easy it is to take an existing Selenium test and add visual validation to it. You can cover entire pages or parts of pages as part of your integration tests. And beyond the fact that it provides you with very strong coverage for how your application looks like, it also becomes a very powerful collaboration tool in the team. Because suddenly you have a place, a single dashboard, where everyone can look and see what changed recently. It doesn't have to be a bug. Perhaps it could be a button that was moved and the product owner is not happy with it. It can immediately provide feedback, and it doesn't have to wait for the sprint or something like that to end to see it. As an acceptance test tool, then it's very common to use the baseline of the previous release and test whatever is about to be released, and then make sure that the only changes are the ones that we intended to introduce. Or another way to do it in a more dynamic environment is to use the production environment as the baseline and validate the staging environment just to make sure that there aren't any unexpected changes before we promote staging to production. And there are many, many companies that actually use visual testing to monitor application in production. There are many reasons to do that. First of all, it allows you to find problems with the production environment that do not exist in your staging environment or development environment, such as missing resources or applications or whatever. It allows you to verify that there are no corruptions in the application due to third-party data. If your application consumes data from third-party application, there might be something wrong with the data which can cause corruption in your website. So this allows you to make sure that that does not happen. And of course, it allows you to detect cases where there are third-party upgrades, like the moment that the browser will update and will break something in your app, you will know it immediately if you continuously monitor the application. Okay, so thank you very much, and if there are any questions, I will be happy to answer. Yep.
In the part of the tool where you said ignore the Google logo moving left, right, left, right,
Mm-hmm.
are you actually planning to ignore that entire section of the page? So like if the Google logo disappeared, then subsequent build can just miss that, or does it go?
So the question was with relation to the floating region thing that we saw before, if the Google logo would go away if we would know it. So yes, of course we would. So the Google logo has to appear intact inside that rectangle, and if it goes away from there, if it disappears, then it's a difference, yes. Mm-hmm.
So your whole page is all floating.
Mm-hmm.
Would you be able to tag your whole page as floating and then have the tool check to make sure that it's filled up with articles?
Yep, so first of all, floating regions only work if the text is exactly the same, if the content is exactly the same. If you have varying data to that extent, so let's say that on the baseline you have a paragraph with 3 sentences, and in the actual image you have a paragraph with 50 sentences in it, then this is something that layout would have to take care of. Okay, you cannot, it doesn't fit, and it's not the same thing that you can search that is moving, because it's just more content, it's not the same thing that's moving. Okay? If, for instance, you would have these two paragraphs and below them you would have something that is fixed, you could use a floating region to make sure that it appears in that column, right? But you would use layout matching to make sure in general that the page is laid out correctly and then not suddenly the paragraph overflows and hides something else on the side that it shouldn't. Yep. It's not configurable. All you need to do is specify that you want to use that match level in your test, and that's it. It doesn't fail, okay? In many cases, the application changes, so it's arguable for me to know if it failed because someone changed the application or there's a bug in the layout engine, but it's very stable. Yes. Yeah, so basically there are several open source tools that use the Applitools engine to work with through the API. And the web application that I just showed you is just a client working in the browser, and everything that it has access to is APIs on the server that everyone can access if they have the correct access keys. So everything is available. Yep.
So let's say I'm in that situation where I want to piggyback off my integration test and splice on this visual testing, but I don't want to affect the execution time of my integration test. Do any of the tools support kind of like asynchronous visual testing so so that the execution time of my test is not affected?
Yeah, so today, so the question was if it's possible to do this async. So the answer is that no, and the reason is that the tool actually waits for your pages to stabilize. And so if you just run along, you might have issues where the page didn't stabilize and you just took a screenshot and moved on, and that's not good. But what you can do is you can have like a flag that actually disables the tool, okay? And then you can have like a quick run of your integration test to give you fast feedback, and then run again async to get the visual feedback. But it's important to remember that when you're doing this type of validation, you shouldn't compare it with other types of automation, because what you're saving here is hours and days of manual labor, okay, which you cannot get with Selenium alone. So anyway, you save a lot of time, okay, even if it takes takes more time than without doing visual validation as far as the automation is concerned. Yeah, okay. So basically, as long as the 3D graphics engine renders deterministically, then it's just the same for this. No problem. You take a screenshot, validates it, so it doesn't matter if it's 3D or not. As long as you get it to be deterministically at the same position and angle and everything. Okay. Yep.
My question was about Eyes, and is it a remote service only?
So the question was, is the Eyes service remote only? So no, it can also be installed on premise. Is that? Yeah. Yeah. Okay. Thank you, everyone. It was great to be here. Thanks.